Hello students, welcome to RD Chemistry. If you are watching for the first time, please do subscribe, like and share the video. In this video, I'll discuss some tricks on bond order and hybridization. So let's start now. Based on molecular orbital theory, we can find out the bond order for diatomic molecules. So remember number of electrons from 10 to 18. So for 10, remember bond order is like 1.0. So increase by 0.5 units. So next one will be 1.5. Then it will be 2.0, 2.5, then 3.0. And after that decrease by 0.5. So it is a 2.5. Then it is a 2.0. Then 1.5 and finally 1.0. So 10 to 18, 1.0 to 1.0. So let us take some examples. Let me consider oxygen molecule. Oxygen atom, atomic number Z is equal to 8. So O2 molecule will have altogether 8 into 2 is equal to 16 electrons. If it is a 16 here, bond order is equal to 2. Correct? So what do you mean bond order? Bond order is nothing but number of bonds between the two oxygen atoms. Right? So let us go for O2 plus. In O2 altogether 16 electrons are there. Plus 1 means it has lost 1 electron, minus 1. So therefore there are 15 electrons are there. If it is a 15 electron, then bond order from the list should be equal to 2.5. Correct? Right? So let me go for O2 minus. O2 minus means there are altogether 16 electrons in the oxygen molecule. Minus 1 means plus 1 extra electron. Therefore, there are 7 electrons. So bond order for 17 electrons should be equal to, it is a 1.5. Right? So similarly, let me write down O2 2 minus. So 16 electrons altogether, O2 molecule plus 2 electrons extra, therefore 18 electron. If it is 18 electron, so it is equal to, bond order should be equal to 1.0. Okay, so this is small trick now. So let us go for N2 molecule. N2 molecule, so if I take nitrogen, its a Z value, atomic number is equal to 7. So nitrogen molecule, therefore electrons are equal to 7 into 2 is equal to 14 electron. If there are 14 electrons, the bond order should be equal to how much? For 14 electrons should be equal to 3.0. Okay, 3, bond order 3. Between two nitrogen atoms there are 3 bonds. This is the meaning, right? So let me go for carbon monoxide now. Now for carbon monoxide CO, two different types of elements are there, carbon and oxygen. Atomic number of carbon is equal to 6 and atomic number of oxygen is equal to 8. So how many electrons are there? 14 electrons are there. So what is the bond order for carbon monoxide? Number of bonds between carbon and oxygen should be equal to 3. Right? Clear? Now how to calculate bond order in resonating structure? When the given molecule ion has got resonating structures. For that you remember bond order is equal to number of bonds between those two types of atoms divided by number of resonating structures. So let me start with the carbonate CO3 2 minus. Correct? So I should write on carbon, central atom 1, 2 and 3 oxygen. Then there are 2 negative charges. So we'll write on minus 1, minus 2, or minus 2. Then other oxygen will have the double bond. Correct? So bond order is equal to, we have to calculate number of bonds between the carbon and oxygen. Now see, around the carbon only oxygens are there. So therefore carbon oxygen total number of bonds are equal to 4. Correct? Around the carbon there are 4 bonds divided by how many resonating structures can be written. So I will not be drawing all the structure. So remember, if there are 3 oxygen, number of resonating structure will be equal to 3. So this number you will have to remember. So 4 divided by 3 is equal to 1.33. Let me take a sulfate, SO4 2 minus. If I write the structure, sulfur, oxygen, 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 correct? Total charges are -2, -1 will write down, then double bond oxygen, double bond oxygen. So bond order is equal to, count the number of bonds around the sulfur. How many are there? 6 are there, right? Divided by how many resonating structures can be written? This number 4. There are 4 oxygen, 4 resonating structure can be written. So this number is equal to 1.5. So bond order is equal to 1.5. Okay. So let's take the example of phosphate, PO4 3 minus. Phosphorus is a central atom. So oxygens are for number 1, 2, 3 and 4. Charges are -3, -1, -1, -1 and other oxygen will have the double bond. So bond order is equal to number of bonds around the phosphorus. Altogether how many are there? 5 are there. Divided by how many resonating structures are possible? 4 are possible. So divided by 4, which is equal to 1.25, right? Next, take the example of chloride, ClO4 2 minus. So chlorine is the central atom. Oxygens are for number 1, 2, 3 and 4. Negative charges are altogether -2, -1, -1. Rest will have the double bond. Okay. So bond order is equal to number of bonds around the chlorine. How many are there? 7 are there. Divided by how many resonating structures are possible? 4 are possible. So divided by 4, which is equal to 1.75. Let us take the last example for this. Nitrate, NO3 minus. Structure can be written as N, oxygen, oxygen, oxygen. Total charge is -1. But if you write the actual structure, around the nitrogen there will be 4 bonds. This should be plus charge, correct? And this will be the -1 charge. So altogether charges are +1 -1 get cancelled, -1 remains. So bond order is equal to total number of bonds around the nitrogen 4 divided by how many resonating structures are possible? 3. So divided by 3, which is equal to 1.33. Right? So this is about the bond order calculation. Now how to find out the hybridization of the central atom? So remember the formula, hybridization, which is equal to V plus M minus C divided by 2. V stands for valence electron on the central atom. M stands for number of monovalent surrounding atoms. C is the charge for cation, anion, not for any neutral atom. So neutral molecule. Okay. Now, so this is a list of valence electron in the p block elements, starting from group number 13, 14, 15, 16, 17, 18. See the group elements there. Boron family, carbon, nitrogen, oxygen, halogen family and the noble gas family. So what is the valence electron group number 13? Valence electrons are 3. Group number 14, valence electrons are 4. Group number 15, valence electrons are 5. Group number 16, 6. Group number 17, 7. Group number 18, 8. Octet is complete for noble gases, right? So pause the video, take the screenshot of this one. Let's proceed now. Now, we are going to get hybridization H value. It can be 2, 3, 4, 5, 6, 7. So accordingly, see the hybridization SP, SP2, SP3, SP3D, SP3D2, SP3D3. And also see the geometry, linear, trigonal planar, tetrahedral, trigonal pyramidal, square pyramidal or octahedral or pentagonal pyramidal. Trigonal, square pyramidal, pentagonal pyramidal, right? Let's take some examples now. I'll start with the simple example. Let's take water H2. Okay, you have to identify oxygen is the central atom and hydrogen monovalent. What are the monovalent? Monovalent elements are hydrogen and all the types of halogens, right? Oxygen. So hybridized H is equal to half into, so V plus M minus C. So half into valence electrons on the oxygen family is equal to 6. Hydrogens are the surrounding monovalent 2. Charge is not there 0. So number is equal to 4. So it is a sp3 hybridized. Right? So let me go for hydronium ion. H3O plus. Hybridized H is equal to half into. Oxygen is our central element. Therefore valence electrons are 6. There are hydrogens 3 number. They are monovalent. So minus. Charge is present. Charge is plus 1. So total is equal to here again 4. Therefore it is also sp3 hybridized. Right? So let's go for the carbonate now. Carbonate is a CO3 2 minus. Hybridization H is equal to carbon is the central atom. So half into carbon family valence electrons are equal to 4. And these oxygen atoms are not the monovalent, they are the divalent. So it is 0. Monovalents are not there. Minus charge is there minus 2. So here it is equal to half into the total is equal to 6. Therefore is equal to 3. It should be sp2 hybridized. Okay. Let's take some interhalogen compounds like BrF3 and ClF5. Okay. So bromine is the central atom, chlorine is the central atom. Hybridized H is equal to half into halogen family. Valence electrons are 7. Fluorines are the monovalent plus 3. Charge is not there. So this is a 10 divided by 2 is equal to 5. So it should be sp3 dehybridized. ClF5. Hybridization H is equal to half into valence electrons of the halogen is equal to 7 plus monovalent fluorine atoms are there 5. Charge is not there. So it is equal to 12 divided by 2 is equal to 6. So it is a sp3d2 hybridized. Right? So these are the small tricks for the hybridization. Please do subscribe RD Chemistry, like and share the videos. Thank you for watching. Have a nice day.